Hello, physics students of Midgard. This is your guest instructor today, Thor, the god of thunder. Now, god of thunder is not my last name, it is Odin's son, but I'm still Thor, the god of thunder, but also electricity, which is what we're going to be talking about today. Let's go ahead and get started. Let's talk about current. Current is where charged particles, they move. Charged particles can move, they can flow, just like water flows. Electrical current is flowing particles. Can you handle that? Oh, there's myself again. It's gorgeous, isn't he? Love my hair. It's a little bit ratty right now, but it'll get better. So what happens is current requires a source of power to make it move, or to generate the energy for the charged particles to go. And that's what power plants and batteries are for. They provide the energy to make charged particles flow, which we call current. And the symbol for electric current is big I. I indeed. Not like the eye that my father, Odin, is missing, or which I'm currently missing. Don't look at it, it's awful. But anyway, current has a unit, and it is called the ampere, represented with a big A. So the current is amperes. Now what it means is 1 ampere is 1 unit of charge. You know, it's a large amount of charged particles that move through a section of wire per second. So you're looking right now at a moving picture called a GIF, where you see these particles and they are moving through the wire. Well, current is the movement of those particles, and it's going to happen over a certain period of time. So the unit of charge is extremely large amount of charge carriers. Those charge carriers, not important right now to know. We'll talk about that right now. What you may have seen on the internet is pictures, moving pictures of how charges they move through circuits. In some pictures you may see the positives, little bitty positives, moving around in a cute little circle like that. But others may have negative charges moving this way. The negatives move through the positive, but in some pictures, the positives move to the negatives. Well, it's a long story, and I'm going to tell it right now. See, 200 to 300 years ago, they discovered this movement of particles. Specifically, it was a chap, a good friend of mine called Ben Franklin. Ben Franklin, he's my boy. He discovered positive and negative essentially. And he figured that it was the positive that moved to negative. And so we have this idea called conventional current. Conventional current is what you're going to see in a lot of physics books and homework and all of that boring earthling stuff. But essentially, as physicists, we know that yes, it is actually electrons that move. They are negatively charged, but based upon our knowledge of how current moves, we just say that the positive is going towards the negative. Don't be confused by that. It's okay if you are a little confused. So we call that conventional current. The opposite is electron flow, where we know the electrons are moving with their energy and they're going from a negative to a positive in the circuit. Once again, it doesn't matter how you think of it. Both models, the conventional current model or the electron flow model, they both work. It's all about being able to trace movement and then using that to figure out various things. So don't worry about it. By the way, it was me that struck Ben Franklin's kite with the lightning. I gave him the necessary electricity, the lightning, to get his experiments going. So you can thank me, Ben Franklin. He's dead though. I'm still alive. So here we go. Oh look, more moving pictures. As you can see, maybe this one up here. See those electrons? Oh, those electrons. They move. They skip. They're skipping from the negative or from this atom to that atom, and they're carrying with them energy. If you look at this picture, you see that the negative electrons, look at them, look at the little things go. They will eventually flow towards the positive. But this picture right here is what I really want you to pay attention to. You see the red arrows, that is conventional current, which for future references, all videos will use conventional current and not electron flow. So don't be confused, it's okay. The numbers still crunch out. It's 6 of one thing, half a dozen of another. That's what my father Odin would say all the time. So that is it for today. There is no more lessons on current. Let me stop sharing the screen so you can see my beautiful face. All right. So I hope you guys are doing well here in your quarantine. I'm God, so I can't get sick like that. But until then, I will see you later.